Welcome to this lecture on the diaphragm. I want you to keep in mind kind of a silly rhyme, and that is C345 keeps the diaphragm alive. At the end of this lecture, you should be able to answer the following objectives. 1, describe the general structure of the diaphragm and its surface projections. List the causes of an elevated hemidiaphragm. Describe its muscular parts and attachments. Describe the apertures of the diaphragm and the vertebral level of transmitted structures, that is, aorta, esophagus, and inferior vena cava. Describe the location of potential herniation sites through the diaphragm. Describe its arterial supply, venous drainage, and innervation of the diaphragm. And then we'll take a look at the key take-home messages with the summary slide, and then provide attribution for the images that are used throughout this lecture. We'll begin here briefly to take a look at the body map, and we'll focus first on the left-hand image and the surface projection of the diaphragm on the right side of the individual here. The diaphragm would ascend after expiration to a point just below the nipple. It is higher on the right side than it would be on the left side, and we'll be able to explore the reason that the right side of the diaphragm is at a higher level than the left. This slide depicts the general structure of the diaphragm. We see the diaphragm right along here, and then extending over to the left side. It does separate the thoracic and abdominal cavities from one another, yet does provide for the transmission of structures between the two cavities, as we'll explore a bit later. It is a musculo-tendinous structure, whereas we have two domes that are more muscular in their construction, and then we have a central area here that is tendinous in its histologic construction. We can see, as we did in the body map slide, that the right dome, or the right hemidiaphragm, does extend more superiorly than does the left dome of the diaphragm. And then the central portion that we see here between the two domes is depressed, and the reason that this central location of the diaphragm is depressed is that the heart is located in this region. This slide depicts the surface projections of the diaphragm. This is seen following normal expiration, and certainly the vigorous nature of respiratory movements could alter the ascension of the diaphragm. So if we had a more forceful expiration, then the diaphragm would be at yet higher levels, and I'm going to depict here for you. Here in the anterior view, we see the right dome of the diaphragm. It typically will rise following normal expiration to the topography of the fifth rib, but in this illustration, it's actually ascended into the fourth intercostal space. If we look at the left view, we'll see that the left dome of the diaphragm is located a bit lower, and it's located in the fifth intercostal space, which we see right in through there. And the reason that the right dome of the diaphragm is at a higher level is the fact that within the abdominal cavity, we have a very large abdominal organ that projects upwards, and that is the liver. It has less of a mass effect on the left side because it's much more diminished in size, so we don't have that pushing upwards of the left diaphragm by any of the abdominal viscera that we do encounter on the right.